Hello, in this video we are going to solve a question of fluid mechanics in which a disk is rotating, a circular disk is rotating with constant angular speed omega. Okay, this is constant angular speed omega. So we are required to find out the drag force on disk and torque required to maintain constant angular velocity omega. So let's start our procedure. Okay, first we are required to find out the drag force. Here we have to take an elemental area. Say for example, we are taking this area at some distance small r. So what will you observe is a circular disc like this. Okay, it will have some area like this. This is going to be dr and this distance is going to be r. So what will be this area? We have to find out. Okay, so this area is going to be 2 pi r into dr, and now since we know the area we can also find out the elemental force, which is going to be equal to tau, that is shear stress, into dA. So what is going to be the shear stress? Assuming that it's a Newtonian fluid, we are applying this equation mu v by h into dA. What is going to be v? Since it is rotating with a constant angular speed omega, so we can simply take v is equal to omega r. So v is omega r by h, and substituting the value of dA, we get 2 pi r into dr. Now this elemental force is 2 pi omega 2 pi mu into omega r square dr by h. We can integrate it from r is equal to 0 to capital R. So this is 0 to capital R. We are going to get 2 pi mu omega by h into r cube by 3. So the first result we have find out that is the drag force required. It is 2 by 3 pi mu omega r cube by h. This is our first result. So we have calculated our force which is required to set the circular disc into a motion of angular speed omega. Now we are required to find out the torque required to maintain this angular velocity. Since this is part 2, since torque is equal to force into distance, so elemental torque will be equal to df into r. So we can take the value of elemental area from this. Okay, and we are going to substitute this value mu omega r by h 2 pi r dr into r. Okay, so let's see what we get. Mu omega 2 pi 1 2 3 r cube dr by h. This is dt. So we are integrating from r is equal to 0 to capital R. So on solving this we will get r की power 4 by 4 integration. So we get answer like this. So this is the torque which will be required to set this into circular motion of angular speed omega. So you can relook at the answer. Thank you for watching this video.